we will be going over problem 2 on the spring 2020 physics exam. In the figure below, a positive point charge plus Q is located at the origin, while two neutral atoms with polarizability A or alpha are centered at D00 and negative D, respectively. After polarization, each neutral atom can be modeled as a dipole P equals QS, so we're given that. And this is very important probably. So on the diagram, sketch the polarization of each atom. So the polarization of an atom means the negative side is more attracted to the positive, and negatives are attracted to positives, and positives are repelled by positives, and same thing, negatives are repelled by negatives. So here we see a positive point charge plus Q, and since there's a positive plus charge, the negative side of the dipole would go toward the positive, and thus the positive side would be this way. And the similar logic we can apply here, get the negative side here and the positive side here. So we have done A. The second question asks, calculate the magnitude of the induced dipole moment of each atom, P equals QS. Express your answer using E0, Q, D, and alpha. So let's think about this. P is equal to QS, right? But we also know this P is equal to alpha times E applied on our formula sheet. So this gives us the E applied would be the EQ, which is the applied force right here. And thus we can say this simplifies into alpha times 1 over 4 pi E naught, because EQ is a point charge, so 1 over 4 pi E naught Q over the radius, or the radius in this case would be distance, right? Since we're given this distance, which is R. So D squared, and this is equivalent to 1 over 4 pi E naught Q alpha over D squared. That's our final answer for that. Part C. Determine the direction of the force exerted on the left polarized atom due to the point charge at the origin. Briefly explain why this force is attractive or repulsive. So let's think about this. Obviously there is a separation distance here between these two, right, of S over 2, S over 2. So the direction of the force exerted on the left polarized atom, which means this atom, due to the point charge at the origin, which means this point charge. So this point charge pulls this atom, pulls this part, the negative end, this way, right? But pushes the positive end this way. However, since we think about what the electric field, we understand that electric field is correlated with the distance or the radius. And since the negative end of the dipole is closer to the positive charge, then the positive end is and the positive end is further away. The negative and positive attraction is stronger than the positive repulsion. Therefore, the direction of the force exerted on the left polarized atom due to the point charge at the origin, the direction of the force is to the right. And now, since it is to the right, positive and negative attract. Therefore, this force is attractive. Why is this force attractive? Because the positive point charge Q is closer to the negative end of the dipole. With that, we're done with parts A, B, and C. Let's move on to part D. So part D asks us to determine the magnitude of the force exerted on the left polarized atom due to the point charge at the origin. Again, we have to express our answer using only these constants and variables. And we can replace this with what we found as it mentions in part B. And again, to reiterate, what we found in part B was this whole formula for PQ, or P equals QS. So the magnitude of the force exerted on the left atom is force exerted on the left atom by, so left atom is dipole. So we'll label the left dipole as LD. So force exerted by Q to LD, which is the left dipole. This is the magnitude. So magnitude would go here. So this is equivalent to the force exerted by LD onto Q, as per Newton's law. Newton's laws, right? So then we can state this implies, this is equivalent to, formula for force is QE, and this would specifically be Q, and this would be E of dipole on axis, because that's because they're on the same axis, right? They're drawn out like this, the dipole here, the point charge here. And so this is the Q from the point charge, which is positive. And so this whole equation, since magnitude, is equivalent to 1 over 4 pi E naught, and then this would be 2Q, and the direction, or the dipole moment vector, P, over the radius, which in this case is distance, cubed, because R equals D. And thus, this gives us, this is equivalent to, now we have to replace P with the formula we found in part B, and in part B we found P is equal to that. So in part B we found P is equivalent to 1 over 4 pi E naught Q alpha over R squared, or D squared. D squared. And so this we just put that in. So 1 over 4 pi E naught 2Q P, or sorry, not P, 2Q over D cubed into 1 over 4 pi E naught Q alpha over D squared. And we can simplify this if we want to. I'm going to go ahead, but obviously I'm sure we can leave it this way. But this gives us 1 over 4 pi E naught squared, and would give us times d to the fifth, and then 2Q squared alpha. There we go. And that is our answer for part D. Part E asks something similar to part C, in that we have to figure out the direction of the force exerted on the left polarized atom to the right polarized atom. So the direction, this force, so if you think about it, we have negative and negative, which are closer than the positive and positive. And the negative and positive are further away than this negative and negative. Therefore, this negative and negative is going to be the strongest affecting charge, or strongest determining factor in the direction of the force. And thus we would have the force direction is to the left and is repulsive because, explain, the neg and ends of the dipoles are the closest and they repel each other. So determine the magnitude of the force exerted on the left polarized atom due to the right polarized atom. So here what we're going to do is write down what we have to do. Force of the left polarized atom by right polarized atom. So right dipole onto left dipole. This is equivalent to force. So this is equivalent to, if we think about it, the force each of the dipoles apply, right? So this has charge polarizability QS, right? So it has like negative, so positive Q charge here and negative Q charge here. So then it becomes equivalent to force, or the right dipole applies onto the negative charge, Q negative, minus the force the right dipole applies onto the positive charge, Q positive. And the reason, because the positive should be facing that way and the negative would be coming inward. So then this simply becomes a matter of understanding that force, again, once from this part, is equivalent to Q and then E dipole axis, right? So this, from there, we get this equivalent to Q times, we would have 2 and then P, because on a dipole, and then this distance would be 2 times distance, right? Because it's this negative d plus, like, this distance becomes 2d, right, from here, but there's separation that we have to factor in. So it'll become 2 times distance minus s over 2 cubed, that's just a formula, minus q, and then 2 times, again, same thing, over 2d, but this time plus s over 2, since there's more distance between the positive and negative end, and then this becomes cubed as well. So now from this, we can plug in our values from, we can say, since we know that Q is equal to P over S, and from part B we know then Q is equivalent to 1 over 4 pi E naught alpha Q over SD squared. We can just, I guess, plug everything in, which would give us, we're plugging in for Q and for P, which we already know from part B, since the Q is equal to P over S and P is equal to P, right? So we would have P squared. So P squared over S. So this simplifies into P squared, and then S goes here, P squared, P squared, and then S goes down here. So if we factor this out, this becomes equivalent to 2P squared, and then we have this negative, and then over S comes out, and then which leaves us with 1 over 2d minus s over 2 cubed minus 1 over 2d plus s over 2 cubed. right? And then we plug back in the value for p, so we get 2 over s, and then p we know is this, so we have p is equivalent to 1 over 4 pi e naught alpha q over d squared. So we plug that in, 1 over 4 pi e naught alpha q over d squared, and then square it, and then we just multiply 1 over 2d s minus s over 2 cubed minus 1 over 2d plus s over 2 cubed. We don't have to simplify this further, and that is our final answer. I appreciate the time that you've taken to watch this. Bye-bye.